We're live. Chapter 8, Sampling Methods and the Central Limit Theorem. So I will be starting on page 247. Why do we sample a population? Let's answer this question. Why do we sample a population?
To contact the whole population will be time consuming.
Time consuming. You individuals that work at the Census Bureau, how often do you run the census?
Every 10 years.
Every 10 years. Why do you not run it every year?
Every 5 years and every 10 years. Economic and ag.
10 years. Why do you run it? Why don't you run it every 1 year?
It's really a huge thing.
Because what?
It's a huge study.
It's a huge study. It takes a lot of time. You couldn't repeat it. You couldn't gather the data and analyze it within the year.
It's a whole United States. And it's expensive.
All right, 2.
Costly.
The cost. It would be cost prohibitive to try to run the census every single year. 3. Let's move from the Census Bureau and we'll start looking at other reasons.
Impossible.
All right, so we'll just say that it's impossible. Give me an example of a sample that would be, or a population that would be impossible. So we're ignoring these two.
Taste test.
Excuse me?
Taste test.
A taste test, worldwide taste test off of the world's population. It would be physically impossible to go out and reach every single member of the world, finding them. Let's just say that we make it even more impossible. A taste test of one crop of apples. Apples would ruin or at least change taste due to fermentation before you got them.
How about taste test of pork? There's certain areas of the world they don't eat pork. Right.
Well, let's just say any impossible barrier. All right, now, give me a 4th example. Destructive. Spell. All right, give me an example of a destructive.
I like the example of Doug Lynn.
Go ahead.
Wine testers at Sutter Home Winery in California drink all the wine to evaluate. I bet they were destructive. They know that's where they get it.
All right, so wine vineyard. All right, but I think of anything usually involving the environment. You know, if I wanted to study, let's just say any particular animal species and its relationship to disease.
Oil in the ocean waters.
Oil in the ocean water would physically be destructive to an animal species or to Mother Earth. All right.
Which way that fire is going to go on a windy day.
And 5, the sample results are adequate. All right, what's this mean? The sample results are adequate. Even if funds were available, it is doubtful the additional accuracy of 100% sample. For example, the federal government uses a sample of grocery stores scattered throughout the United States to determine the monthly index of food prices. Okay, if we're actually looking at the CPI or inflationary numbers for food prices, this is how we gather the data. It is unlikely that the inclusion of all grocery stores are going to change the output. I mean, if I came into select grocery stores in your town, just think of nothing else due to capitalism and competition. But if I went into the grocery stores in town, I'm probably going to see pretty common for like product, probably going to see pretty common pricing. So the fact that I come in and, you know, just here locally, we have Meijer and Kroger in each other's backyards. Okay, yes, I realize on any given day certain products are going to be at different prices, but across the board, a pound of beef is going to be worth a pound of beef. For exact like product, we're probably not going to be a whole lot of variation between the two. All right, commonly used methods. So we'll say here, common methods. What's the first?
Simple random sample.
Simple random sample. Give me an example.
Nobody's going to have drawn them out.
When you think of a simple random sample, I want you to think of hat. All right, I've got 1,000 people that work for me, and I want to sample my population of workers. Draw everyone and put everyone's name in a hat, draw from the hat. All right, in that example, every member has an equal chance of being drawn. No one gets a leg up, no one gets preferential treatment. Everyone has the same random chance of being drawn. Next. All right, and I will tell you that in your text, you have a chart of simple random numbers. Microsoft Excel has an add-in that you can run simple random numbers.
You can straight Google.
I was going to say you can Google random numbers, and it's going to use and give you an output of random numbers. Just don't try to use your head. Because if you think about random numbers in your head, we have bias in our head. So the first number you're probably going to say might be your favorite number or some number that you associate with. So be sure that we have to strip out any form of bias. Be sure you use one of these methods for generating these for you. All right, number 2.
Systematic random sample.
Systematic. Random sample. All right, what's a systematic random sample?
For the first integers randomly picked, and then you have even intervals between it and the next numbers in a list.
Like you're gonna pick every 10.
All right, so correct. So let's look at this example. 845 employees. A sample of 52 will be selected from that population. Okay, in this example, they took the 845 employees and divided it by 52. In this case, saw that they would select every 16th employee. So you're right, you start with some value, and then you use equal gaps, pulling additional members of the sample in.
That's what we would have brought up, man, in our discussion.
All right, I'm going to put a note here. I just looked in the book. That's Appendix B4. for your simple sample. All right, but a systematic. What do we do when, in this example, pay is not a whole number?
That's a question.
All right, so in this example, 845 employees. So remember, 845, and it says that we were going to do, so 845, and we were going to draw we wanted 52 people. All right, so that equals 16. So we would take our employees and we're going to select every 16th employee. Now, what happens if my output here does not equal a whole number?
You have to round it.
I have to round it. Which direction?
Down.
Round down. Okay, number 3. Stratified random sample. What's a stratified random sample?
Population divided into subgroups.
Like male, female.
And then a sample is randomly selected from those subgroups.
All right, so these subgroups we're going to call strata. And we are going to pull from each strata. Well, it gives you a good example. Suppose you want to study the advertising expenditures for the 352 largest companies of the United States. You want to determine whether firms with higher returns on equity spend more of each sales dollars on advertising than a low return. So the return on equity, financial terms, measure of profitability. So firms who spend more, do they have higher profitability margins than firms who spend less on advertising? Decide to sample a total of 50 companies. Now, to make sure that the sample is a fair representation of the 352 companies, they are grouped on percent return on equity. So you're going to break them down into 2 groups, 2 stratas. Strata 1. All right, look at the top of page 253. Well, let's just say we're going to break them down into 5 stratas. Here's what the book's doing. How do we define the first strata? Companies with 30% ROE and greater. So these are going to be companies that have high profitability margins. And then you're going to go 20 to 30 in strata 2, 10 to 20. So what I want you to look at is so that you have fair representation. Go back. It would not be fair to look at the companies that had very large profit margins and trying to compare those to those that have low to none. Okay, so we're trying to group into separate classes, taking those firms that are highly profitable and ranking them and looking at them within their own profit margin. Comparing like numbers, like results. All right, and number 4, we have a cluster. And what's a cluster sample?
Population divided into clusters using naturally occurring geographic or other boundaries.
All right, commonly used with naturally occurring geographic or other boundaries. So suppose you want to determine the views of residents in Greater Chicago about state and federal politics, state and federal protection. politics. Okay, you can employ sample clusters by subdividing the groups by counties. Look at page 253. We see the counties of Greater Chicago metropolitan area. You see a boundary here of Lake Michigan. And then you see the counties from the southeast, south, west, all the way to the northwest. So all the way around this area. And we're going to, once we divide it into clusters, we are then going to use simple random samples out of each cluster. Okay, let's look at an example. Now, what if, why do we sample to begin with?
We're looking for like a certain thing, like.
We do a sample to tell us more about the population. Tell us something about the population. Does that mean that my sample is going to tell the 100% complete story of the population? No. So whenever you see the term sampling error, we're talking about any difference between the population variable and the sample variable. So if I looked at what's that tell you? The difference between
the mean of the sample and the mean of the population.
Correct. So the difference between the sample mean and the population mean.
Would be an S.
Go back to the first video, first chapter. What's the S tell me? What's the S a variable for?
That is standard
Okay.
deviation of a sample.
I knew that.
Excuse me?
Standard
I knew that.
deviation of
The standard deviation of the sample.
I
You
knew
asked
that
that question earlier.
I know it.
There you go.
I had that on my mind.
I knew we would come up to this
I
slide.
looked this up on my chart earlier too, so I knew this is one.
All right, so
We'll forget now, that's for sure.
there you go. You know, the difference between the variance and the standard deviation from the sample to the population. So sampling error is the error that occurs between the 2 points.
What was your bottom on there, SPO2? Oh, that's the, yeah.
Okay. Any questions?